All right, perfect. Hey everyone. Today we're going to be talking about Espresso. It's an intent-based cross-chain swap secured by Espresso Finality. So the problem I was trying to solve is basically cross-rollup bridging is pretty broken today. We really only have two options. Either you can bridge via the parent chain or go through either a centralized or some sort of optimistic relayer. Um, Native bridge via parent chains is obviously pretty bad. It's not bad. It's just very slow. Where, for example, if you want to go from something like Arbitrum to Optimism, go from Arbitrum to ETH, wait 7 days, then go from ETH to Optimism, wait another probably like 20 to 30 minutes, and it's just really really slow to do this. Secondly, we have obviously like centralized or optimistic relayers. So this works pretty fast. You can get funds within a few seconds, but most of these solutions today rely on centralized sequencer confirmations, and there's like some open questions or like some tricky situations you can end up in. And for example, what happens if there's a reorg on Arbitrum, or what happens if the sequencer doesn't end up submitting that transaction in its next batch to Ethereum? And the solvers or fillers who are sort of looking at this intent hub and filling these orders based on sequencer confirmations, they can lose funds if the sequencer misbehaves for whatever reason. So Espresso obviously here provides a confirmation layer that guarantees the sequencer will necessarily post the batch to its parent chain. So we have like a pretty strong inclusion and finality pre-conf that we're getting from the rollup, and based on this, enter Affogato. So Affogato as a system, what it is it's three rollups, all of which are use Arbitrum Sepolia as the parent chain. The three rollups are named after Starbucks cup sizes, by the way. So there's tall, grande, and venti. And for each rollup, we have I have a Nitro node that's running. I've open intent framework contracts that have been deployed to each of them, Hyperlane contracts that have been deployed to each of them, and then a caffeinated node, which is the Espresso preconf node that's running for each of the rollups as well. Then on top, I have this custom filler and rebalancer that I built that I'm running as well. That's looking at the CAF nodes for each of the three chains, and there's the Hyperlane relayer that I'm running that's also passing messages back and forth to three chains, and then a UI I made just to make everything simple. So the idea with Affogato is that users can cross-chain swap or bridge between any two rollups in a matter of seconds with pretty strong security guarantees. So for example, if we're going ETH to USDC from Tall to Grande, you open an order to sell ETH on Tall. Espresso provides a pre-conf for this transaction through like the Tall CAF node. The filler is looking at this pre-conf, is looking at the CAF node. It finds the pre-conf and fills the order on Grande, giving the user their USDC. Then they initiate a settlement process for this transaction on Grande, saying, I've filled this order. Espresso will provide a pre-conf for the settlement transaction on Grande, and the Hyperlane relayer is also listening to the CAF nodes, and it looks at this pre-conf and relays a message back to Tall, and eventually the order is marked filled on Tall, and the filler receives their ETH. So, and also if necessary, the filler will initiate a rebalancing process. So just to expand on that a little bit, periodically, like let's say if the filler starts off with like 0.25 ETH and 100 USDC on each rollup, eventually as the intents come in, as it does swaps and stuff like that, it may end up with a heavily biased bag of tokens on one rollup and very few tokens on the other. So the way I have it set up right now is once every hour, it's going to run a background job to figure out if a token balance is below a certain threshold on any one of the chains, and if it is, then it will go through the native parent chain bridge route to actually rebalance tokens across the three chains. And I've enabled like fast withdrawals in my case at least, so it doesn't take 7 days. But either way, in a more production setting, you would probably use some sort of clearing layer like Everclear or something over here to make it a little bit faster as well. Anyway, jumping into the demo, you can go try it yourself at affogato.harddisk.dev. You do have to bridge ETH over to the rollups. You can find instructions for that in the README later. But for now, let's say it's a pretty simple UI. So currently, you can see I have like balances on 3 chains, like my balances and then the filler's balances. So currently, I have like some amount of ETH across all the 3 rollups. I don't have USDC on Tall. I have like little USDC on the other 2. And the filler is maintaining an inventory of tokens across all 3 rollups. The price of swapping between ETH to USDC is very fake here. It's hard-coded to 1 ETH equals 2 USDC, just because it's testnet and limited testnet tokens. But what I'm going to show you is, let's say we go 0.01 ETH. Let's go from Grande. So currently have 0.29 roughly on there. And we're going to go get some USDC on Tall, which currently I have 0 USDC on Tall. So if I just do a swap, oops, did I select the wrong wallet? Hold on. Live demos, am I right? Okay. Grande, USDC on Tall. Swap. There we go. Cool. Sign this. So what's going to happen is, I create the order on the origin chain, and we can actually look at this if I head over to, this is my filler logs that are coming through. There we go. So you can see it's got an open event on Affogato Grande, filled the order on Tall. So if I go back, so yeah, I filled the order on the destination chain, initiated a settlement transaction, and then Hyperlane looked at the pre-conf of the settlement transaction, and we can look at Hyperlane logs here as well. It's a bit old. Let me fetch new ones. There we go. So there you go. So yeah, it relayed a message. It observed a message coming from observed a message from Tall to Grande, the opposite direction, and then relayed it over there. So this is done. And if I close, you can see 0.01 ETH got deducted from here, and I have a little bit of USDC on Tall now. Going back. Yeah, if you want to check out the code or other information, it's all open source on GitHub over here. I kept this one short because we only had a few minutes to present, but happy to answer any questions now if you have some.
That's great. Thank you so much, Hardik. We do have questions. Let me bring to the stage here Ellie and Connie from Cross. Let me bring Wheat again as well. Whoever wants to go first. Connie, do you want to start?
Hey, Hardik, good presentation and a really, really good project. The design you created, it sort of begs for its own implementation of ERC 7650. Specifically, that's a contract that can talk between Espresso rollups. Do you want to shed some light on how you may have worked on your own implementation of ERC 7683 and how it is helping this particular design?
Yeah, so the 7683 contracts, I didn't really change them from what the Open Intents framework gave me. What I did change was the filler mainly. So like the way I've designed my filler is it works everything, it does everything based off of like pre-confs coming from Espresso. And then the Hyperlane relayer is also set up in a way where it only works off of pre-confs coming from Espresso instead of the regular Nitro nodes. But the contracts are just the standard OIF contracts. I didn't change anything in there.
Understood. Cool. Thank you.
Also, huge shout out to Across for co-authoring that standard. Love that.
All right, my question is about kind of your use of Hyperlane. So I was wondering, did you use like the default ISM of Hyperlane, or did you adjust it for your own? Like, how did you change, Hyperlane to be able to use the Espresso confirmations versus, what it does today by default?
So it does use the trusted ISM setup right now. It's a single signer, specific private key right now. It's not, looking at a validator set of any sort. But the way it works is for the CAF node, it was relatively simple where it just I just pointed to the RPC of the CAF node, and the CAF node only, it's like fetching events from the CAF node basically. And if the CAF node finds a transaction, it's reading from Hotshot. So if the CAF node has the transaction or has the events in the first place, that means it got them from Hotshot, which means there's the Espresso confirmation there.
All right, perfect. Thanks.
If no one has any other question, I'm just gonna bring here the slide.